So, I believe that we are up to looking at our calculations involving reactions on the end of page 50. This is our next bit of theory. Now, we already did mass calculations. For solids, and we know that we had to go via moles. Remember doing that, we've already done this. Now we're going to do the equivalent, but with solutions. So if you look at our work example on the top of page 51, it asks us how many moles of sodium carbonate are needed to react completely with 50 mL of a 2.21 mole per litre solution of nitric acid. Like all chemical equations, we're going to, or calculations, we need the equation, and we need it balanced. So we have sodium carbonate. Now, this, it didn't tell us it was a solution. We're only finding the moles, so we're going to assume it's a solid. We're using nitric acid, which I haven't really spoken to you much about yet, and we'll talk more about acids in the next couple of lessons. This is nitric acid. It's one that you must learn. Along with the one that you're already very familiar with, which is hydrochloric. And sulfuric. Okay, so those ones you just have to know. Not on the formula sheet. You don't have to memorise much. When I was at uni, I had to memorise the periodic table.
Can you still remember? Do you still remember it?
I still remember.
I'm nearly there.
The whole thing.
I've got up to which one? Most of it. All of it?
Let's get on with that. But the point is that you aren't really expected to memorise much. And like when I did my HSC, because I'm from New South Wales, we do the high school certificate, we didn't have cheat sheets for any subject. So we had to memorise everything, all the equations.
I memorised up to hydrogen in the periodic table, see?
Oh, well done you.
Thanks.
And you will be able to see this reaction on our formula sheets. Like I said, we haven't really looked in depth at reactions of acids. But if you look at the reactions of acids on your formula sheet, you'll see that if you react an acid with a carbonate, you produce a salt plus carbon dioxide plus water. And the salt is going to be dependent on what ions are present. So in this case, we're going to produce sodium nitrate as the salt. Of course, the sodium has a +1 charge on its ion and the nitrate's a -1. Then they join together in a 1-to-1 ratio. And the two must go out the front as the coefficient then to balance the quantities. And this is aqueous. All of our acids will be aqueous. Okay, it's an acid because it's, we'll talk about what's required for acids, like I said, in the next lesson or so. But they're always going to be in solution. So our other products, like I said, are carbon dioxide and water. And as it turns out, this is balanced. You don't need to do any more than that. So we were told that we had the volume of our nitric acid, was 50 mils, which we must convert to litres. 0.050 litres. And we were also told the concentration of the nitric acid was 2.21 moles per litre. Now, if we get stuck, if we forget, we can always go back to that volumetric page or calculations for chemical reactions of our formula sheet to remind us that if this is the two pieces of information that we are definitely going to be, we're definitely going to be using this formula for the formula sheet, which means that we can find the number of moles of nitric acid. 95% of Calcs involves finding moles. If you're not sure what to do, find moles. Remember to multiply our volume in litres. So it's going to be 0.050 times 2.21 gives us 0.111 moles. Now that tells us how many moles we used of the nitric acid. At this point, we now look at the mole ratio from the balanced chemical equation. And we were asked to determine how many moles of sodium carbonate are needed. So we haven't written the 1 because we're lazy, but there is a 1 there. So our mole ratio of the sodium carbonate to the nitric acid is 1 to 2. That means I need twice as much nitric acid, twice as many moles of nitric acid as I need of the sodium carbonate. So therefore, the moles of sodium carbonate is going to be 1/2 times 0.111. And that gives us 0.056 moles. Now that's the answer to question 1. If we were to continue on, maybe we might be asked what mass, and then we should be able to work from these moles of sodium carbonate to work out what mass. So for example, we would be using this relationship here, and we would need to find the molar mass of sodium carbonate. 2 times 22.99 plus 12.01 plus 3 times 16. We would need that information there, multiplied by the moles, to determine the mass, to make sure that our reacting quantities are perfectly balanced. The example for example number 2 is to try and find a volume. So here we were finding moles. What is the volume of a 1.47 mole per litre hydrochloric acid solution that is needed to react completely with 2 grams of zinc? Again, this is a reaction of a metal with an acid. And if you look on your formula sheets, you'll see that it will produce a salt plus hydrogen gas. Now the salt has to be zinc chloride because they are the only ions that are present. What charge on a zinc ion? 2. What about a chloride ion? -1. Yep. So when we balance our zinc chloride, we're going to need 2 chloride ions for every zinc ion. So remember that if we're not sure, we have to go back looking at our table. And our other product is hydrogen gas. We have to remember that hydrogen gas is diatomic. Right? It it's not just H, it's H2. And so if I balance this, I'm going to need a 2 there, aren't I? Then I believe it's balanced. So we want to know how much, what volume of that hydrochloric acid we need to react completely with 2 grams of zinc. We've got 2.0 grams of zinc. We can't calculate, we can't use the grams, we must find the moles. So in this case, we know that N is equal to the sample mass divided by the molar mass of our solid. So the moles of zinc equal 2 grams divided by the atomic mass of zinc, because it's an element, which gives us 0.0306 moles. Now we can look at our equation, back to looking at our mole ratio again. So there's our invisible one that we haven't written. This time we had calculated the moles of zinc we have, and we need to know the moles of hydrochloric acid. So therefore the moles of hydrochloric acid will equal 2 times this. Sorry, didn't do it as a separate calculation. Okay, so that's how many moles of hydrochloric acid we need. Now, because we want to find the volume of a solution, we have to go back to using our C equals N on V relationship. If I'm finding volume, these will swap around, so volume will equal the moles divided by the concentration. So my volume then of hydrochloric acid will equal the moles 0.0612 divided by concentration we're given in the question, which was 1.47 moles per litre. Remember, all of our calculations are in litres, so when we're finding the volume, our answer will also be in litres. Sometimes, because we often work in volumes in mils in chemistry, we might change that to mils. You don't need to do that necessarily unless the question tells you to. This would still be considered correct and 4 marks. Let's do our final working example together. What mass of lead iodide is formed when 25 mils from a pipette of 0.492 moles per litre solution of potassium iodide is added to a solution containing excess lead nitrate? And we're given the equation. So we have lead nitrate, we have potassium iodide, forming lead iodide. This is a precipitation reaction that we've done before, and our potassium nitrate is our, these are our spectator ions. We want to find the mass of lead iodide that's going to be produced, and we reacted 25 mils. So we know our volume of potassium iodide is 25 mils. So it's 0.025 litres. And we know that the concentration of the potassium iodide is 0.492 moles per litre. Notice in my setting out that I'm putting brackets, and I'm saying in brackets what it is that I have written here. This is very good setting out for you for physi and for chemistry, because the more complicated a reaction becomes, the harder it might be for you to follow or to go back and troubleshoot your own working if you haven't given you a roadmap to find what you've been doing. Now, again, because we've got our volume and our concentration, the first step is going to be to find the moles of potassium iodide. So N will equal C times V. And 0.0123 moles. So we've used the information given in the volume and the concentration from the question. Now we wanted to find the lead iodide, so we're interested again in our balanced equation. We've got our one that we didn't write here and our two here. So we're really only interested in the ones involved in the calculation for our mole ratio of Ki to PV line 2 is 2 to 1. So therefore, the moles of lead iodide is going to be what? Half or 2? Half. Notice as well, no coefficients in all of this. The only time we are interested in the coefficients of the balanced equation is here. And this is where it would account for that difference. If I did it twice, because I've seen some people put coefficients in the brackets, I actually cancel them out. And so then we haven't got them there anymore if I do it. So we have then there's 0.00615 moles. And this is pretty straightforward again, but now we wanted to find a mass. The sample mass will equal the moles times the molar mass. So we're going to need to determine the molar mass of lead iodide. It's 207.2 plus 2 times 126.9. 469.0 grams per mole. So we have the moles and we have the molar mass. So our mass of lead iodide, 0.00615 times 461.0 gives us 2.84 grams. Now, this setting out is also helpful. Just writing out the information that's been given in the question can guide you as to the approach to take to solve it too. And because you're writing out the information and you can see what's the next step I can take. We can always, like I said, 95% of the time we can find moles, and we also will very much need to know the mole ratio in the balanced equation. If you left that step out, and you just assumed a one-to-one relationship where it wasn't, you could, depending on how big the question was, it would be a 1 or maybe 2 month. any questions or comments, or how